All right, so in this video, we are going to be looking at similar triangles. Now, similar triangles come from a dilation. Now, when we have dilated triangles or polygons, all the corresponding angles are congruent. In other words, they're equal in measure, and also the sides are proportional. So that's what we're going to be looking at in this video here. We'll be looking at the angles of similar triangles, and we'll be using proportions to find missing side lengths in triangles. It's indirect measurement. All right, so if we have similar triangles and we know that the corresponding angles are congruent, in other words, they have equal measures for the angles. So basically what we're trying to do is match up the angles of the triangle. So let's look at this angle right here. Its corresponding angle is 40 degrees. So if it's 40 degrees on this triangle, then it's going to be 40 degrees on that triangle because they're corresponding angles. Likewise, if we're looking over here, that's going to be corresponding with this angle. So if this one's 30, then that one over there is 30 degrees as well. Now, to see if triangles are similar, you only need to match up two of the three angles, because check it out here. In order to find this third angle up here, we need to start with 180 because all three angles add to 180, and then we're going to subtract off the 20 degrees and also subtract off the 90 degrees. So that's going to make this angle 70 degrees. So if we know 2, then we can find the third one. Now check it out with this other one. Start with 180 to find this angle here, and you're doing the same thing. 180 minus 20 minus 90 equals, again, 70. So now we have all the corresponding angles are congruent, where we only needed 2, because in triangles, if you know 2, you automatically know the third one. All right, let's look at this example here. So now these two triangles are similar. Triangle ABC similar to triangle DEF. This symbol does mean similar. Now these two triangles have been like flipped and rotated and all that stuff, so they don't match up perfectly like the last ones. So we have to use the notation up here. So if you look here, the A and the D are in the first position, so that means vertex A and vertex D are corresponding vertices, or corresponding angles in this case here. The middle ones, that's the B and the E. So that means that B and E are the corresponding vertices. And then looking at the lasts, C and F, there's C and F in red. So again, when they've been flipped and rotated and stuff, you have to use the notation up here because they don't match up just by the picture. So here we're trying to find the measure of angle E. So angle E right here marked with an X, it's in green. So remember, E was in the middle and B is in the middle, so that means those two vertices match up. So if B is 52, E is 52 because they are corresponding angles. All right, so are these two triangles similar? So basically what this question is asking is, are the corresponding angles congruent? So do our angles match up? It's kind of what we're thinking here. So let's just look at this angle right here in the corner. I got it in yellow. So X should be, so if these true triangles are congruent, its corresponding angle would be here. These two are corresponding, so X should match. It should have a congruent angle measure. So X should be 55 degrees. So now let's actually calculate the measure of angle X. So again, with interior angles of a triangle, they add to 180. So we're going to subtract the two other angles, the green angles, from 180. So the 77 plus the 46 makes 123. Now, of course, you could do it like what we did on the last example there, where we just subtract 180 minus the other two, looking like this. Either way, X actually equals 57 degrees. So are these two triangles similar? No. If they were, X would be 55 degrees, but instead it's 57 degrees. So now let's look at sides of similar triangles. So here's 3 similar triangles up on the screen. Side lengths of the one on the left, 6, 8, and 10. We got 3, 4, and 5 for the middle one, and the big one, 9, 12, and 15. So we're going to be looking at the ratio of side lengths. So we're just going to be using right away just the green and the orange one. So that's going to be a 4:3 ratio for these two sides here. Looking at the same two sides over here, again, we're looking at corresponding sides as being 8:6 ratio, which is the same. It reduces to 4/3. And then for the big one, that's going to be a 12:9 ratio, which also reduces to 4/3. So the pairs of sides here all reduced to 4/3 so that we have equal ratios. So in other words, the side lengths are proportional. And this works even on the other sides. Like 5 to 3 is the same as 15 to 9. They both reduce to the same thing, 10 to 6, or you can go 10 to 8, 5 to 4, and 15 to 12. All the pairs of sides are proportional. All right, for this example, we are going to be finding this missing measure here, this x right there. So since these triangles are proportional, they're similar, so the sides are proportional, we're going to write and solve a proportion. Now, a proportion is two equal ratios. So we got a ratio here equals another ratio here. So this ratio on the left, we're going to do with the triangle that's on the left. So we're going to use the 48 and the 66 because they correspond with the x and the 77. So here we go, 48 for the numerator and then 66 for the denominator there. So there's our ratio on the left side for the triangle that's on the left. Now the ratio that's on the right, we're going to use the triangle that's on the right. So the side lengths, x, which is what we're trying to find, and then 77. So there are 4 different correct proportions that you can set up. This is just one of those 4. And then for solving these, there are different ways you can treat it like an equation and undo operations. But for this one here, we're going to do cross multiply. So here we go. We want to figure out what x equals. So we're using cross multiplication. So we're going to do 48 times 77, cross multiply there. And then for the other diagonal, 66 and times x. So again, we're trying to get x by itself here. We want to undo the times 66 to the x, so we're going to do divide 66, and this goes to both sides. So we already know that 66 over 66 is 1, so 1x is just x. And then for this left-hand side, doing the calculations, we'll do these off to the side. So we can do like a cross-canceling type idea. And so we're looking at 77 over 66. Well, we can divide them both by 11. So here we go, 77 divided by 11, 66 divided by 11. And then we can do further canceling or removing of common factors. So in this case here, the 48 and the 6, they're both multiples of 6. So we'll remove a factor of 6 from both the numerator and denominator. And again, we're thinking division with that. And so we end up with 8 times 7, which makes 56. Now, it is okay if you want to go ahead and use a calculator. You can totally do that. I got that shown on the screen as well. So there you go, solving using a proportion for a missing side length of similar triangles. All right, for this example here, we are going to be finding the measure of this length here. Sometimes we'll see triangles similar to what's going on, like if you have something really tall and then something smaller and there's some sort of shadow involved and you end up with a big triangle and then a smaller triangle there, which are similar. So that's what we're going to be doing here. We're going to be finding the value of this length here, which is where that person was standing. And so we are going to do write and solve a proportion. Now, when you have overlapping triangles, sometimes it is a good idea to go ahead and redraw it so that way the two triangles are not overlapping anymore. So we can redraw the small one off to the side. And now we're ready to write out our two equal ratios. So this first ratio, it'll go with the small triangle. So the triangle that was red there. So x for the vertical side, and then 63 for the green, the horizontal side. So there's our first ratio with the small triangle, and then our other ratio will go with the big triangle here. So the two sides that we'll use is the 55 and the 99, so 55 over and then 99. And now it's similar to the last example. We're just going to solve using cross multiplication. So we want to figure out the value for x. So we're going to do cross multiply. So we're doing x times 99 for that first diagonal that we're multiplying, and then the second diagonal is going to be 63 times 55. Now we do want to get x by itself, so we have x times 99. We just want regular x, so we're going to undo that times 99 with a divide by 99, and this does go to both sides. So we know 99 over 99, it basically goes bye-bye, so it leaves us with just x. X times 1 is just x. And then we can go ahead and simplify this up before we calculate it. So the 55 and the 99, both divisible by 11. So we're going to remove a factor of 11 from both of those. So that's going to make 5 over 9. And then looking at this pair here, the 63 and the 9, we can also remove a factor of 9. We're thinking divide by 9 when we're canceling or removing factors. So 63 divided by 9, 7. And so we end up with 7 times 5, which makes 35. Now, again, just like the last one, if you need a calculator, go ahead and pull one out and use that as well. And that's all there is to it when you're solving using proportional type ideas with these similar triangles. So quick sum up, remember with similar triangles, the corresponding angles are congruent or equal in measure, and then all pairs of corresponding sides are proportional. They have the same ratio. All right, so I hope this helps out. I hope you have a great start to your day, rest of your day, or evening, or whatever time you might be watching.